Good morning, children. So last class I've started. I've given you that is introduction, reactions involving cleavage of COH bond. That means OH is being released. Got it? That we have started already the last class, where the the alcohol acts as it is nothing but an electrophile. We can say that alcohol acts as an electrophile. Already I have discussed with you these things. Now I have told you that in that case the 3-degree alcohol is more reactive than 2 degrees, more reactive than 1 degree, more reactive than methyl alcohol. I have told you the reason also, that is OH group is readily released in case of tertiary, then secondary, then primary, then methyl alcohol. Why? Because the polar bond is maximum in case of tertiary, then secondary, then primary, then methyl alcohol, the tertiary bond. Why? Because the carbon atom in tertiary alcohol is more electronegative in nature, then secondary, then primary, then methyl alcohol. Why it is more electronegative? Because 3 alkyl groups are there, 3 donor groups are there, due to which the tertiary carbon atom is more electronegative in nature. The electron density is more there in case of the carbon atom. Now, due to that particular reason, what you find is that it is going to repel, because OH is also negative, electronegative, and tertiary carbon atom is more electronegative compared to secondary, primary and methyl. Due to this reason, the repulsion is more in tertiary alcohol than in secondary, then in primary, then in methyl alcohol. If the repulsion is more, the stability is the least, due to which the cleavage takes place readily in case of tertiary alcohol, then secondary, then primary, then methyl. And hence you find that 3-degree alcohol is more reactive than 2 degrees, more reactive than 1 degree, more reactive than methyl alcohol. I have discussed with you the last class. Once again, I said you, just to remind you, because I am going to start the reactions now. Got it? Are you following, children, what I am talking to you? Now, next is, if you see here that when it reacts with halogen acids, as I said you, here it acts as an electrophile. So hence it's going to react with a nucleophile. That is, we are going to get it, that is I minus, then nothing but Br minus, Cl minus, F minus. So already I have discussed with you in the halogen chapter, that is haloalkanes and haloarenes, that due to the nucleophilic character of the halide ions, got it? What you can say is that I minus is more reactive than Br minus and Cl minus. Simple, I can say to you that in case of halogen acids, Hi is more reactive than HCl, HBr than HCl than HF. You know that. Why? Because the bond length in case of Hi is a maximum. So hence the reactivity is also the maximum. Why? Because the bond cleavage takes place easily. So the reactivity of the halogen acids with alcohols, if you see, it follows the order. Hi is more reactive than HBr, is more reactive than HCl, is more reactive than HF. And in case of alcohol here, that is 3-degree alcohol is more reactive than 2 degrees, more reactive than 1 degree, more reactive than methyl. I think it's clear. The basic part is being clear to you. Now, next what we are going to see, we are going to see, that is the reaction with these halogen acids of this particular alcohol. So already we have seen the reactions in the halides chapter. Here we are going to see a test. The name of the test is a Lucas test. Mind it, it's very important. It differentiates 3-degree, 2-degree and 1-degree alcohol. So listen, children, carefully. So what is a Lucas test? You have to take a Lucas reagent first. What is Lucas reagent? A mixture of conc HCl and anhydrous zinc chloride in the ratio of 1:1. Mixture of conc HCl and anhydrous zinc chloride. You can see it on the screen. I have written it. Anhydrous zinc chloride in the ratio 1:1. Now, why do we take anhydrous zinc chloride? I have discussed in halides. Still then, once again, I will say anhydrous zinc chloride here solves 2 purposes. Anhydrous, that means it acts as a dehydrating agent. It helps in the removal of water, first of all. Clear? Next, second thing is that as it is Lewis acid, got it? It helps in the cleavage of C single bond O. It helps in the cleavage of C single bond O bond. Got it? It helps in the cleavage, being a Lewis acid, because it pulls electrons from oxygen. Clear? And hence, what you can say is that the bond gets weakened. Which bond? C single bond O bond gets weakened. And due to the weakening of this particular bond, it breaks to form a carbocation. The carbocation then readily reacts with the chloride ion to form chloroalkane. Got it? Because generally I am going to take here chloride. You can take bromide also and you can do the reactions. Got it? Clear? You can take iodide also. I told you Hi is the most reactive. I have told you already. But here I am taking an example. As you can see is there I have taken HCl. So I am talking about, for that reason, chloride. Got it? Understood? The anhydrous zinc chloride, it acts as a dehydrating agent, helps also acts as a Lewis acid. It helps in the cleavage of C single bond O bond. Got it? Due to this reason, a carbocation is being formed, and this carbocation reacts with the halide ions. Got it? That is either I minus, Br minus, Cl minus, anything, and it forms what you can say the respective halides it forms. Here I have taken HCl, so I talked to you about chloroalkanes. Now, as I said you already, that tertiary alcohols being highly reactive. Got it? It's being highly reactive. You can say the tertiary alcohol. I have told you already. Now, how we will prove that it is highly reactive in nature? Now, look at the screen. You can see that CH3CH2OH when reacts with that is your Lucas reagent, the HCl conc and anhydrous ZnCl2. No turbidity we get it at room temperature. Turbidity means what? Milkiness. Got it? That is called turbidity. Got it? Milkiness, milky, the solution. No, we did not get at room temperature. If on heating only, you may get it. I have written it. That may appear on heating. If you heat it, then you may get some turbidity. But otherwise, at room temperature, you will not get it. Okay? Why? Because less reactive in nature. The primary alcohol is the least reactive. Now, secondary alcohol, you see. You take Lucas reagent. Got it? You take Lucas reagent there. In secondary alcohol, when it reacts with Lucas reagent, then what you get? You get turbidity after few minutes. Few minutes means, let us say within 5 minutes you will get a turbidity. Got it? After 5 minutes or within 5 minutes you will get a turbidity or milkiness. It is more reactive than primary. For that purpose you get it. In primary you won't get it. In tertiary alcohol, here I have written Lucas reagent. Got it? That's true. But if you won't take anhydrous ZnCl2, simply if you take conc HCl, then also the reaction can be carried out. You remember it, I told you in what you can say when I was teaching you the halides. Got it? So here I have written Lucas reagent because the Lucas test, so I have to write it down. But Lucas reagent is not necessary here. Let me tell you. You can also do with conc HCl. Anhydrous ZnCl2 is not necessary here because tertiary alcohol is so reactive that without anhydrous ZnCl2 also the turbidity appears immediately. You take tertiary alcohol and you add conc HCl. Got it? You will see turbidity appears, milkiness appears immediately. So hence, what does it prove? That tertiary alcohol is more reactive than secondary, is more reactive than primary. It's a very, very important test to distinguish between secondary, primary and tertiary alcohol, so to say. I think it's clear what I said to you. Got it? Now, next is if you do this reaction with HBr, got it? Then you have to take conc H2SO4 and you have to go for refluxation. You know what is refluxation? I said you that in the liquid state they are less reactive in nature. Which one? That is alcohol and HBr, they are less reactive in nature. So hence you have to use a reflux condenser. There you have to put this particular two liquid and you have to heat it. In the vapor state they are going to react with one another. So that is known as refluxation. So if you take ethyl alcohol or any alcohol and you react with HBr in presence of conc H2SO4 and you go for refluxation, then what you will be getting? You will be getting the respective halides and water will be released because conc H2SO4 acts as a dehydrating agent. We are not taking an anhydrous ZnCl2. Okay, mind it that. Now, what you can find is that the mixture of KBr and H2SO4 is not used in case of secondary and tertiary alcohols. Why? Because to prevent their dehydration. Noted this particular thing, children. Note it. That is what I said. That is a mixture of KBr and conc H2SO4. I am not using it in the example which I said you, C2H5OH plus HBr. What was C2H5OH? Primary alcohol. I did not say secondary alcohol. I did not say tertiary alcohol. Alright, it cannot be used in secondary and tertiary alcohol. Why? Because to prevent their dehydration. When the dehydration is going to take place, it will not give you what halides. It may give you alkenes. Alright, it may give you alkenes. For that particular reason, we are not using, that is conc H2SO4 in this case. Understood? Now one more thing I'll add it here, that if you are using that is what you can say HI. Got it? If you are using HI, then ethyl alcohol, you react with HI and simply heat it. Nothing is required. Ethyl alcohol plus HI, you simply heat it, you will get alkyl iodide. You will get alkyl iodide. Got it? For example, if you take, got it, methyl alcohol and HI in presence of red phosphorus. You know why red phosphorus is used? Because HI is such a strong reducing agent that it will make the reaction reversible at 423 Kelvin. Then you will be getting methane plus water plus iodine. All this reaction I have said you in halides chapter. I have said you in halides. In the preparation of halides, you just see it. I have already said you. Just I am saying you this particular one for your reference to make you remember that what we have done it. Got it? In halides little bit about it, because it is related to alcohol also. For that reason I am saying you. So what I said, that for Lucas test generally we take HCl conc and ZnCl2. Got it? If you want to react with HBr, then you take conc H2SO4 and go for refluxation, but not with secondary and tertiary alcohol, because dehydration will take place to such an extent that it may give you alkenes. And with HI, you are simply heating it with primary alcohol or any other alcohol. You are simply heating it. No anhydrous ZnCl2, nothing is required. But one thing you have to remember, that you have to take red phosphorus and if to heat it, what is that? Temperature is 423 Kelvin around. So you will be getting, that is nothing but methane, or you will get ethane and water and iodine, we can say that. Got it? And if you heat it very what you can say, to a small extent, then you will be getting alkyl iodide also. Got it? Clear? So this proves the reactivity of HI is greater than HBr is greater than HCl, and also it shows that tertiary alcohol is more reactive than secondary, is more reactive than primary. I hope you understood. Any doubt you can ask me. Any doubt, I have said you always.